Is our last day before my spring break. Looks like Moss and you guys have the same spring break, so we'll both get to enjoy a week off next week. Um, our next class after today will be on March 27th. So any of the time between now and then, of course, you'll get either a free period during this time or time to catch up on anything that you need to. I'll make sure all the videos from this week are updated. Maybe not by the end of the day today because I'm on the road for the rest of the day today, but they will be updated by the end of the day tomorrow so that all the recordings are there for you to watch and keep up or catch up if you need to. So anyway, we've been talking about dilutions and solution concentrations and stuff like that, all leading up to what we're going to do today. To start off today, I want to talk about constituting a solution. And this is an important concept because many of our medications, even ones that are liquid solutions, get shipped dry. What that means is in order to save on shipping weight, because a lot of shipping goes by package weight, it'll get shipped in a vial with just a little bit of dry powder in the bottom of the vial. That powder is our medication. And so then on site, when you go to use it, you'll need to constitute the medication. So shipping is one of the main reasons why we do ship it dry, and so we save money on weight. But the other thing is once it is constituted, once the water is put into it and it's now a solution, now it has an expiration date. Dry powder will keep a lot longer than a wet solution. So that's the second reason why we ship medications and store them in that dry state, is so that if we need to store them for a while, they can sit there and we don't have to worry about any sort of spoilage or contamination with that medication. So then the label might say, or the instructions might say, if it's in a separate pamphlet with the medication, it might say constitute with 4.8 milliliters of sterile water to 25 milligrams in 5 milliliters. So all this is saying is that when you go to constitute the solution, you take 4.8 milliliters of sterile water, or NS as we've been calling it, and you will inject it into the vial. And then, of course, shake it up, mix it up, whatever. The result, once you do that, should be a total volume of 5 milliliters. So what this is saying is the powder that was in the bottom of that vial was 25 milligrams of medication. So we add the 4.8 milliliters of water, and the total volume will now become 5 milliliters. And so the concentration, this is a weight in volume concentration, as we learned from Wednesday, is going to be 25 milligrams in 5 milliliters of total solution. And realistically, for our purposes, this is the only thing we care about, is that concentration, the final concentration. As long as we make sure we correctly constitute the solution, this is the amount then that we're going to work with later. Or we might have a label that says something like constitute with 18.9 milliliters of sterile water to 50 milligrams in 20 milliliters. So similar thing here. This is saying that our final volume, well, first of all, it's saying we're going to add 18.9 milliliters of NS, or stale water, to this vial. And once we shake it up, mix it up, we're going to have a total volume of 200 milliliters, and it contains 50 milligrams of medication. So when we go to do our dosage calculation, again, it's this part of those instructions that is going to tell us the actual concentration of the final solution so that we can figure out our dosage calculations. The final piece that we need before we get into the actual calculation of the dosages is our medical abbreviations. And these are found in your textbook on page 150. And I should state, I am not going to quiz you on these abbreviations. There's never going to be anything on a test that says, what does the abbreviation IV stand for? But you do need to understand these abbreviations well enough because we're going to use, some of them are going to be significant in our dosage calculations. First of all, it might give how the medication is delivered to the patient. PO means orally. IM, intramuscularly. So it's an injection directly into the muscle. IV is the tricky one. Intravenously. Intravenously means you actually have to find a vein with the needle to get it directly into the bloodstream. Other abbreviations talk about frequency of medication, like Q4H. That means administered every 4 hours. Of course, along with that, Q6H, Q8H, every 6 hours or every 8 hours. Again, you need to know that frequency because if we're doing a safe dosage calculation, and the safe dosage is a certain amount every 6 hours, but the doctor has called for a certain amount Q4H every 4 hours, then we've got to adjust that concentration to make sure it is safe based on the different administration intervals. And then we might have something like PRN, which is just as needed. So in this case, the doctor might not prescribe an exact amount and exact intervals, but would give you a maximum, like a daily maximum of, no more than 2,000 milligrams a day, or might break it down even further, no more than 500 milligrams every 6 hours. And there are other ones like 2IB, means twice daily. And again, I'm not going to go through all of them here because I'm not going to test you on them. They're all on that page 150 again. So you can take a look at those. I would maybe just bookmark that page. So as we're doing dosage calculations, you can flip back quick and see what those abbreviations mean so that you can figure out how to do the calculation, what the numbers are, how it affects your dosage calculation. So with that all said, we are going to start the meat and potatoes of Unit 3, and that is dosage calculations. There are actually 3 main methods that are used in practice for dosage calculations. I'm going to go over them in order of what I least like to what I like the most. So I'm going to start with the one that is probably the most prescribed. And by that I mean it is, you have to memorize it because you're not going to just figure it out, reasoning through things. And that is the dosage calculation formula. So actually, before I get into that, I should probably go through a little bit of the process. So what we're going to be dealing with 3 different amounts here. The first is the doctor's order. The doctor is going to say the patient needs this much medication. Well, then we have to look at what's called the on-hand dose. On hand would be like what's at the nursing station if it's a standard medication, or in the medicine cabinet, what's the label on the solution, on the vial tell us for concentration. We're going to deal with that. That's going to help us determine then what the third amount is, and that's what goes to the patient. I mean, ultimately, that's what we're looking for is what do we put into the patient to get this medication where it needs to go? Now you might say, well, why doesn't the doctor just say give the patient 2 capsules or whatever? Well, the doctor's not going to say that because the doctor may not know exactly what is at the nurse's station. Even acetaminophen comes in 150 milligram tablets, 500 milligram tablets, 300 milligram tablets. There's all different sizes of tablets for that medication. The doctor may not necessarily know what is at the nursing station, or may not know just what the nurses prefer to give to the patient. So the doctor's orders are going to be a specific amount, but usually in terms of milligrams or international units or just units, or some other unit that is very specific, not non-ambiguous at all. And then what's on hand, that's going to have to get translated based on what our supply on hand is. So again, it might be a 200 milligram tablet or 25 milligrams and 5 milliliters like we saw up above, whatever that concentration or whatever the on-hand dose or supply is. And then, of course, there is a term that we've discussed before, but what carries that on-hand dose into the patient is called a vehicle. Could be a solution. So if it's a solution, that vehicle is the milliliters of solution that we're injecting either intramuscularly or intravenously into the patient. Could be a tablet. So it'd be the number of tablets we give to the patient. Or it could be a capsule. So it could be capsules is going to be our vehicle. So that dosage calculation formula uses 4 prescribed amounts. So it starts off with, let me get my screen out of the way here. Starts off with the doctor's orders, D. Well, let me just fill the formula up here. So it's D over H times V equals A. So this is the doctor's order. And again, that'll be that specific amount, whether it's milligrams or international units or whatever, that the patient needs to receive of that medication. H here is the on-hand dose. So that again is what's at the nurse's station or in the medicine cabinet. Might be capsules, how much is in a capsule, or the concentration in a solution or whatever. These two must have the same units. If they don't have the same units, then we're going to have to convert, because the units on those two amounts have to cancel out in this formula for the formula to work. Next, we have V, which is the vehicle. And as we said before, this is what carries the medication into the patient. We'll say just carries serum into the patient. And finally, A, this is what is actually administered. So that might be a number of tablets. It might be milliliters of solution given to the patient. It's what we actually give to the patient in order to get that medication into them. So to demonstrate each of the 3 methods today, I'm going to do a few different examples. I'm going to do the same examples for each method, just so you can see how it works with each. So we're going to start out here with an order of 500 milligrams of ibuprofen. And our supply, in other words, what's at the nurse's station? 200 milligram tablets. Now I should make a note about tablets. This does not say scored tablets, but usually it would say scored, and most tablets are scored. If we're administering a medication in tablets, we can go to the nearest half of a tablet. So we'll look at that rounding, probably not today, but when we come back after spring break and some of our examples as to where we might have to round because of that. So for our formula, again, D over H times V equals A. Well, D, the doctor's orders, that's pretty easy to pick out of here. That's the 500 milligrams. And of course, we need the ibuprofen because that's specifying what medication we're going to administer. Now, again, with the on-hand dose, H, that's what we have on hand. That's the 200 milligram tablets. Now, this is actually giving us both H, the on-hand dose, and the vehicle. The 200 milligrams is H because that has the same units as the doctor's order. The one tablet is the vehicle. So that said 200 milligram tablets, but we can take that to be that 200 milligrams is equal to one tablet. So one tablet becomes the vehicle. So now the milligrams cancel out in this calculation. 500 divided by 200 is 2.5. And 2.5 times one tablet is going to give us 2.5 tablets. So we administer 2.5 tablets of ibuprofen to the patient in order to meet that requirement for that medication. So our next example. The doctor's going to order 200 milligrams to be administered intramuscularly. So this is going to be some form of a solution. We find our vial. I'm going to read on the supply that solution is constituted to 25 milligrams in 8 milliliters. So again, my formula, D over H times V equals A. D is the doctor's orders. Well, that's pretty simple. That's the 200 milligrams. I did not specify a medication here, but knowing that it's being administered intramuscularly means we know it has to be a solution, it has to be a fluid. Now the on-hand dose has to have the same units as the doctor's orders. So 25 milligrams is the same unit. That's our on-hand dose. And again, the vehicle is what carries that on-hand dose into the patient. Well, that 25 milligrams is in 8 milliliters. So 8 milliliters becomes our vehicle. And now we just solve the equation. So the milligrams cancel out. 200 divided by 25 is 8. 8 times 8 milliliters is 64 milliliters that we're going to administer to the patient. Now, at this point, a lot of students really like the dosage calculation formula because it's prescribed. You just plug the numbers in and calculate it out. And that is the strength of the dosage calculation formula. If I can. I did that. I was right the first time. Anyway, and that is because it's prescribed. Not much room for change there. You don't have to interpret much of anything other than picking the information out of what's given. The major weakness, though, is it's not very versatile. In fact, if we get into a more complex situation, we're going to have to use it more than one time, sometimes several times. Let me show you what I mean by that. Let's say we have the doctor's order is for 200,000 international units of a medication. Now, the thing with international units is international units are different size depending on what the medication is. So we might look up in a reference of some sort that tells us for that medication, 100,000 international units is 2 milligrams. And then if we look at the supply on the bottle, it is constituted at 8 milligrams in 5 milliliters. So I can use the dosage calculation formula here, but each time I change units, I have to apply the formula. So I'll start with the doctor's order, 200,000 international units. Now I know that international units has to go on bottom here. The 100,000 international units is the only other number I have that has international units as a unit. And of course, the 100,000 international units is contained in 2 milligrams. That becomes my vehicle. So the international units cancel out. 200,000 divided by 100,000 is 2. 2 times 2 milligrams is 4 milligrams. Now, that is not what's going to be, we want 4 milligrams to go into the patient, but that's not the final vehicle to get this into the patient. So we have to repeat this calculation now to convert that 4 milligrams into an administrable dose. So the 4 milligrams, if we look at our supply, is contained in 8 milligrams. So that's the only thing with milligrams is the unit that goes below it. In 5 milliliters. So 5 milliliters is the vehicle carrying the 8 milligrams. Now the milligrams cancel out. 4 divided by 8 is 0.5. Times the 5 milliliters is 2.5 milliliters that's administered to that patient. So you can see we have to apply that dosage calculation formula repeatedly when we have a more complex setup like that. Our next method, which is a little less prescribed, is a proportion. And a proportion, again, its strength is that we just have to match up units. The weakness, same as with the formula, is that it might have to be replied repeatedly. Now, the proportion is a little bit flexible. Sometimes it's listed using the same abbreviations as the dosage calculation formula, is H over V equals D over A. So you input the doctor's orders here. This is the information off the vial. You get the amount to administer to the patient there. Others listed as the amount to administer to the patient over the doctor's orders equals the vehicle over the on-hand dose. Same relationship, just set up differently. And there are at least 2 other ways that formula could be set up that would still work the same. Actually, there's 6 other ways that proportion could be set up that would still work. We either have to match the units side to side like that, or we have to match the units up and down. One of those 2 ways has to match up. So let's go through our examples here. We're going to use this version, by the way. So our first example is the doctor orders 500 milligrams of ibuprofen. And we look at our supply, and it is, again, 200 milligram tablets. So that proportion is saying we take the doctor's orders, goes over here, so that's the 500 milligrams. On this side, It's the on-hand dose. Well, the on-hand dose has to have the same units as the doctor's orders because they're side to side. So that would be the 200 milligrams. So you can see, just like in the dosage formula, the doctor's orders and the on-hand dose had to have the same units. In the proportion, they have to have the same units as well. And then the vehicle carrying the 200 milligrams is a tablet. So what that tells us is, first of all, the units here are also going to be tablets of some sort. And then to find the missing value in a proportion, we cross, multiply, and divide. 1 times 500 is 500. Divided by the 200 is 2.5. So that comes out to be 2.5 tablets. On to our second example. So we had an order for 200 milligrams of a medication to be administered intramuscularly. And when we looked at our supply, the label says 25 milligrams in 8 milliliters. So again, we use that proportion. Doctor's orders goes over here. That's the 200 milligrams. Well, since that's milligrams, this has to be milligrams here for the on-hand dose. 25 milligrams is our on-hand dose. And that 25 milligrams is in the 8 milliliters, so the 8 milliliters becomes our vehicle. So again, that tells us that what's administered to the patient is going to come out in milliliters in this formula. So we cross, multiply, and divide. 8 times 200 is 1,600. Divided by 25 gives us 64. So we would administer 64 milliliters of that medication to the patient. Now again, just like with the formula, at this point you might be looking at this proportion saying, wow, that's really quick and simple and easy to set up. And it is, but again, when we get to a more complex example, like again, the doctor ordering 200,000 international units. And then we look up in a reference again, and we find that that's 100,000 international units for that medication in 2 milligrams. And our supply is labeled 8 milligrams in 5 milliliters. So again, we could set up our proportion. Doctor's orders go here. That's the 200,000 international units. Well, international units has to go over here as well. The only other thing labeled international units is the 100,000. And that is found in 2 milligrams. So what we're going to get over here is going to be milligrams. We'll cross, multiply, and divide. So 2 times 200,000 divided by 100,000 is 4 milligrams. Now this is going to be some sort of an injected administration here. So we have to get this into milliliters. So we got to go another step. We set up our proportion again. This is now going to take the place of the doctor's order, because that's what we've converted the doctor's order into, is 4 milligrams. This has to be milligrams over here as well. Well, we have 8 milligrams in 5 milliliters. So the 5 milliliters becomes the vehicle. So this over here is going to be milliliters, which is what we're looking for. We'll cross, multiply, and divide. 5 times 4 is 20, divided by 8 is 2.5 milliliters. So there's that weakness of the proportion. Is in a complex problem, we have to administer it or apply it multiple times. Here it was only twice, but we have some complex problems where it would have to be administered at least 4 times. Getting us to the last method we have, which is my personal favorite, and that is dimensional analysis. We've mentioned dimensional analysis several times before. All it is a fancy word for measurement conversions. In other words, using the units to change the amount to where we want it to be. If we get the units to the correct unit, the amount gets to the correct amount as well. The nice thing about dimensional analysis, some people think it's a weakness, but I think it's nice, is there is no set formula with it. There's nothing to memorize. We just start with the doctor's orders and we convert to what's administered to the patient. I don't like memorizing formulas because you end up with too many formulas and you have to keep them straight. There would be like 7 or 8 different formulas for dosage calculations if we did that route. But here we can have that order for 500 milligrams of ibuprofen and our supply of 200 milligram tablets again. So the trick here is, remember, any rate was also an equivalency. So that 200 milligram tablets is saying that 200 milligrams is equivalent to 1 tablet. So now we can use that as an equivalency to convert our doctor's orders to a different unit. So our order is 500 milligrams. We put that over 1, just like we did with our measurements to make them a fraction so we can convert. And now, to get rid of milligrams, we put milligrams on bottom, and we know 200 milligrams is equivalent to 1 tablet. Now the milligrams cancel out. 500 times 1 tablet is 500 tablets. 1 times 200 is 200. And then we just divide. 500 tablets divided by 200 is 2.5 tablets. Or for our second example, where we had the doctor's order for 200 milligrams to be administered intramuscularly. And our supply, if we look on the label, we say it is constituted to 25 milligrams in 8 milliliters. So this one works the exact same way. We start out with the doctor's order of 200 milligrams. We put it over 1 to make it a fraction so we can start our measurement conversion process. We're getting rid of milligrams, so I'm going to put milligrams on bottom here. This 25 milligrams in 8 milliliters, once again, that is an equivalency, saying 25 milligrams of medication is equivalent to 8 milliliters of fluid. So 25 milligrams and 8 milliliters. The milligrams cross cancel. 200 times 8 milliliters is 1,600 milliliters. 1 times 25 is 25. And we divide that out. 1,600 divided by 25 is 64 milliliters. Now you might be looking at this, and with these first 2 examples, you might actually prefer one of the first 2 methods, either the formula or the proportion. And I get that because a lot of people don't do their measurement conversions formally like this using the dimensional analysis. But we run into problems like that third example that we had, where the order was for 200,000 international units. When we looked up in our reference, we found that 100,000 for that medication, 100,000 international units was found in just 2 milligrams of medication. Then we look up in our supply, the label says 8 milligrams in, 8 milligrams in 5 milliliters. So now both of these become equivalencies. This one becomes that 100,000 international units is equal to 2 milligrams. This one becomes 8 milligrams is equivalent to 5 milliliters. And now we start out with the doctor's orders and we just convert it until we get to something we can administer to the patient. The 200,000 international units, it's put over 1 to make it a fraction. Now we have international units here, so we have to put international units here so that they cancel out. The only thing we have with international units is that 100,000 international units equals 2 milligrams. So now the international units will cancel out. We have milligrams. Well, we have milligrams on top. To get rid of them, I need milligrams on bottom. So the only thing I have with milligrams is this equivalency here. 8 milligrams equals 5 milliliters. Now the milligrams cancel out. And the only units we have left is milliliters, which is what we want to be able to administer to the patient. So on top here, we have 200,000 times 2 times 5 milliliters. That is going to be 2 million milliliters. On bottom, 1 times 100,000 times 8, that's 800,000. I got my comma in the wrong spot there. 800,000. And then we divide. So it's just going to be 2 million milliliters divided by 800,000 is going to give us 2.5 milliliters. So we get the same result, but this is all done in one long process. Now again, at this point, these are relatively simple examples. Any of these methods are going to work pretty well for the examples that'll be in the homework today. As we move on, though, and get into IV flow rates and stuff like that, dosages based on weight or body surface area, the calculations become more complex. So it's definitely to our advantage to use this dimensional analysis. Otherwise, we'd have to repeat the process several times in any of those others, or we'd have to memorize a new formula for IV flow rates. So with that, I'll give you some homework here. Try and get this to scroll. There we go. Okay, so our homework, I know we're a little bit early, but we'll let you start your spring break a few minutes early. So page 153, 154. 1 through 15, I'm going to have you do all those. That is the medical abbreviation. So again, I'm not going to test you on it, but make sure you go through them so that you know them well enough that when you're reading through the problems, you understand what the problem is saying. And then page 162 through 163, 1 through 23, the odd. This is doing different dosage calculations. Pick a method and stick with it. Like I said, I highly recommend dimensional analysis. To me, it's the one that's the most versatile. It works in every type of problem we're going to do this semester. But pick which method you're going to like for now and use it and get good with it. And then, of course, the page that I'm not going to put up there is the syringes from Wednesday on page 168. If you haven't done those, make sure you look over how to fill a syringe and figuring out the scale that's on a syringe. Okay, so we're about 6 minutes early, but that's okay. You guys have a great weekend. Actually, have a great week off, and we'll see you on the 27th.